The superposition principle in mechanics states that the net effect of two or more forces acting on a body is the sum of the individual effects of each force. This principle can be applied to solve a wide variety of problems in mechanics, including beam deflections. The superposition principle can be used to calculate the deflection of a beam under multiple loads. This is useful for designing beams and other structures to ensure that they can safely support the loads they will be subjected to. Vibrations. The superposition principle can be used to analyze the vibrations of systems with multiple degrees of freedom. This is useful for designing systems to avoid resonance and other vibration-related problems. Wave propagation. The superposition principle can be used to analyze the propagation of waves in various media, such as sound waves in air or light waves in glass. This is useful for designing optical and acoustic devices. In general, the superposition principle can be applied whenever the system under consideration is linear. A linear system is one in which the output is proportional to the input. For example, a spring is a linear system because the force required to compress or extend it is proportional to the amount of compression or extension. Here are some specific examples of when to apply superposition in mechanics. A beam supported at both ends with a concentrated load in the middle. A cantilever beam with a concentrated load at the free end. A spring mass system with an external force applied. A pendulum with an external force applied. A system of two or more coupled masses. A wave propagating through a medium. It is important to note that the superposition principle does not apply to all systems in mechanics. For example, nonlinear systems, such as those with friction or hysteresis, do not obey superposition.